Okay. In yesterday class we have discussed all about this attribute closures, the super key, okay, super key and the candidate key, prime attribute and prime attribute. So what is prime attribute? A attribute which is the part of a candidate key in the relation in the table. Those are called primary attributes. The other are non-primary attributes. So the attributes which are part of a candidate key, So those are called primary keys. Sorry, prime attributes. See, if it is candidate key, right? These are the parts of candidate key. This is the prime attribute. Okay, so here employee ID is a prime attribute, remaining all non-prime attributes. Okay, so which is the part of the candidate key, that is the prime attribute. What is super key? Super key is a set of attributes or one single or set of attributes, singular set of attributes used to find a unique row. Okay, unique value, unique row. So you need to find a unique value. Unique row to find the unique row. So this is the set of attributes or single attributes. So we can call as super keys. Okay. So in this, we can find the candidate keys. So minimal of super key is called a candidate key, right? So in this case, what is the candidate key? Employee ID is a candidate key. That means minimal of super key is called candidate key. Here employee ID, here EMP ID, here EMP ID, EMP ID. So here EMP ID. Then if it is other number, individually another number is candidate key, employee ID also candidate key. By using this candidate key, you can find unique row. So unique row, if I want to find the value, so you can, by using employee ID, we can find the value of the department, right? Department ID we can find, or if I use other number also, I can find the department number or the name of the employee. So it represents unique. But because of candidate key, we can find the unique row, unique value from the relation. Okay, those are called the candidate keys. So we can say the super key also same, right? So you can find the unique row by using one or multiple set of attributes is called super key. So super keys, so of super keys called key. Okay, so these are the candidate keys. Coming to closer activity, we should follow this algorithm to find the closer activity. I already explained with that examples. Okay, functional dependencies, finding functional dependencies and closer activities. So we have the problems on that. You need to solve it. I will share the document. You should solve the problems. How I solved it. Okay. All right. Today we are going to discuss of the normalization concept. So normalization, that means we are avoiding redundancy problems, inconsistency. These problems we are avoiding, we can reduce by using the normalization concept. See, normalization is a process of designing a consistent database with minimum redundancy, which supports data integrity by granting and decomposing the relations. We are decomposing the relation by using the decomposition. We are reducing the redundancies and the inconsistency data integrity. It supports the data integrity. So how we are decomposing? So one table we are making it small tables, multiple tables, so small tables. So the decomposition given relation into smaller relation, preserving consistency of the preserving constraints on the relations. Example. Okay. So this relation removes the data redundancy and will help designing a good data. A good data is a set of normal forms. Okay, a set of normal forms. Here normal forms means what? These are all normal forms. We have first normal form, second normal form, third normal form, Boise code normal form, and fourth normal form, fifth normal form, sixth normal form, domain key normal form. Okay, in this way we have normal forms. But still fifth, fourth, enough. Okay, till fourth, it's enough. Okay, fourth normal form. So till this we are enough to decompose. Okay, these normal. What is the normal form here? We can define normal form. Uh, so we can define a normal form here. Here normal form means, so it's a set of rules to perform decomposition. Set of rules, by using the rules perform decomposition. Set of rules to perform decomposition. This is the definition of normal. How many normal forms? We have 8 only, and so we will discuss today first normal form. First normal form. Okay. Second normal form. Okay. It is in shortcut. Order way. So order means DCNF comes first. Let's say that is 3.5 means half of the column. So I score normal. DCNF Y score normal form. I score the in this way, normal forms. Here we can see. Okay, 3NF, 4NF, still domain key normal form we have. See, we need to apply these functional dependencies and rules. We need to follow some rules. The first normal form. See now what is normal form? Set of rules to perform the decomposition. Need to perform, if you want to perform decomposition, we need to follow some rules. Okay. In the first normal form, see the example. Say I'm creating one table. Student ID. And the student course. Okay. Student ID. Student ID. Next course C, C++, multiple. Next, one or two. Courses like Java, next one or three. Okay, so one or three. So this is the table actually we have. So in this table, what is the drawback? See, first, if it is, we need to convert it is in first normal form. Now it is in not in first normal form because it contains multiple values within the one column. Okay, so first normal form means what? It avoids the multiple values in the single column. Okay, it contains only single value for the single cell. So for single column, only single value must be there. Okay, so not like multiple values in the single column. So how to decompose it? How to decompose, ma? Tell me, decompose, how to decompose it? Decompose this table. Decompose it. So what is primary attribute? Prime attribute SID. Say candidate. Okay. So now you no need to decompose like two tables. So within the one table we can do it this. See, we have the table. So only avoid the multiple values and into one column. Okay, right. Voice is audible to you or not? Okay. Here, are you getting my voice?
Yes, sir.
See, we have in the course column, we have multiple values. What is the drawback? See here, if I trying to delete the course C, so in this column, this C++ also will going to be delete, right? So we will get data inconsistency problem. So to avoid this, what is the solution? We need to follow the first normal form rule. So those that the column contains only single value. Okay, we need to represent in this format. So 101 name is Siva. So and his course is what? C. Not one Siva. The course is Java. So course is Java. Next 102 course is. Tell me someone give the reply. Are you understanding or not? Instead of multiple values, we are inserting single value. 1 or 2 to avoid the data inconsistency problem. Program that contains C++ three values completed. Next 103. 103 is okay and having OS. Next having 5. I can decompose it. See, I avoided multi-values here, multiple values in the single column. We are avoiding and we are writing like this. Okay. So what is the problem if I write like this, multiple values in a single column? So if I am trying to delete the course C, so it is going to delete C++ also, right? So data inconsistency. So to avoid that, so we need to decompose in this way. That is the rule of first normal form. I think you clear about this, right? Have you understand?
Yes, sir.
Yeah, we need to decompose this slide. Okay, this is about first normal form. Okay, second normal form. So first normal form we are avoiding multi-valued attributes. Avoiding multi-valued attributes. So you can write like this. Multi-valued attributes. These are very, very important. Please try to understand. Avoid multi-valued attributes. Okay. So second normal form. In second normal form, what we need to do? What is the rule? What is the rule means? What is the rule for second normal form? The rule is must not contain any partial dependency. Not contains any not contains any partial dependency. Partial dependency must not contains any partial dependency. Partial dependency means so every non-prime attribute must be fully dependent on the candidate key. See, that means you should be fully dependent on the candidate key. Okay, remember this point. That means what? Partial dependency. Partial dependency means what? Dependency means every non-prime attribute must be fully dependent on the candidate key. Every every non-prime attribute must be fully dependent on okay, on the candidate key. Okay, then it is in the second normal form. Okay, so non-prime attribute, every non-prime attribute must be fully dependent on the candidate key. should dependent on the candidate key. You should not depend partially. Okay, you should be dependent fully. That means what? Fully on that candidate key. Okay, candidate key. Understand how you can see. Most in the example, then you can understand easily. Okay. We have non-biometric. So candidate key having the primary form candidate attribute that we call prime attribute. Candidate table then we call prime attribute. The rest of other attributes are all prime. See, see the example form. So it should not be partial. Okay, so must be fully dependent on and okay. Decompose.
Sir, your voice is breaking.
Oh,
No, sir, it's still like that.
okay. We have attributes and the location. And location is attribute, but it's actually depend upon these two. Actually depend upon the new attributes and attributes. So there should not be a dependency. Is second normal form group. So we did how we can divide it. So we perform decomposition operations like this. Fully dependent. See, one table to two tables. So that we I deconstruct okay. Yeah. So I divide next the location. So then location. So in this way I can decompose it. So that means what? This location we in the department, from the department. Okay. So before it is partially dependent upon the department ID and the employee ID. So now I decomposed it. That means the second normal form rule is what? It should be fully dependent. So to make it fully dependent, so it should be a separate table and it should be a and I decomposed this table with the EID, location, the second flow department. Now there is no partial dependency, no dependency. Because here another no attribute, right? Another no added attribute. We can attribute that is department, so that location is fully dependent on the department ID. This is the second normal form. Okay. Second normal form rule is what? Must not contain any partial dependency. Fully dependent to the non. Okay. So non-prime dependent on them. I think we just right. So non-prime, fully functional depend on the. Next thing is what? Third normal form. Third normal form. Here the question is what? In the third normal form, what is the rule? What is the rule of third normal form? Answer. So there should be no transitive dependency for non-prime. Transitive dependency. Transitive rule, right? What is the transitive rule? What is the transitive rule? What is transitive? See, here is the attribute A and then I can write A C. This is the transitive rule, but we need to avoid this.
So,
No.
so your voice is breaking.
Voice is breaking.
No, but still the same.
Same. I will remove emails. Now is it audible? Sir?
No, sir.
Now, now it's breaking.
Yes, sir.
Okay, can't be able to hear. Uh, third normal form. Third normal form condition is what? Rule is what? Transitive functional dependency. There should be no transitive dependency or non-prime. No transitive dependency or non-prime. So transitive dependency means what? A determines B, B determines C. Then I can write A determines C. This is transitive dependency, right? So we should avoid this. How to avoid this? Okay, that is our normal form. That is our okay. How to avoid it? So create one table here. Next. I have 5 attributes. 1, 2, 3. First one, student ID, student name, subject ID, next subject name, address. So I'm inserting data here. And ID. And use subject ID, and subject name, then address, so yeah. ID student name ID location and something. So this is so it contains the trans dependency. So I need to avoid it that decomposing this table table like this. So here find the prime attributes and non-prime attributes. So here primary key is entering see here subject ID subject name. So these are different right from this. So we divide with these attributes. So first we write the attributes. Subject ID. Is decomposing. What is remaining? So subject ID and the subject name. In this way, okay. So these all attributes depending upon the SID. Okay, this one, and this one. Also dependent. Next, this attributes so depend on. So there not be a turns to B turns to C, then A turns to C. I cannot write. Okay, so we are avoiding this here in the okay. So this is about first normal form, second normal form, and the third normal form. Next one is BCN, normal form. What is normal form? Rule is not boys for normal form. The rule is every functional dependency then A has to be here not trial functional dependency. Okay. So nearly not till that to repeat it once. Okay. Tomorrow we will see the normal form. So normal form. So normalization concept means what? We can perform decomposition. So design consists of data memory dependency by decomposition of the decomposition means what? We can decompose into multiple tables, okay, based on the first normal form rules. That means normal form rules. So here normal forms means what? So it's a contains rules to perform decomposition. Each normal form having their own rule. Okay, based on that rule, we are decomposing the normal form. Here, see briefly, you can see from the first normal form, we are avoiding what? So no repeating groups. There should be no repeating data groups. Okay, that means the group of values should not be in the one column. Like course is to, C, C++. We have multiple values in the same column. We are avoiding that. Okay. Then second normal form. What is the second normal form? No partial key dependency. We are avoiding partial key dependency between the attributes. So I decomposed into two tables. This is second normal form, right? So I decomposed into two tables where we can see here. Here is second normal form. See here. So here we have a partial dependency. So this location we can find by using employee ID, DID. So this is partial dependency. So we are decomposing into two tables. So this location must be fully dependent on the department ID. Okay. So we are following second normal form rule. There not be a partial dependency. Okay. So third one is what? Or normal form. So no transitive dependency. Transitive means A turns to B, B turns to C. Then I can write A turns to C. That we should avoid here. We cannot write like that. A turns to C. We should not write. We should avoid it. How to avoid that? Okay. So by decomposing the table. See, we will see. Next to boys code normal form. In this form, we are avoiding reduce the key dependencies. Next to fourth normal form. So here no multi-valued dependency. In the fifth normal form, so no join dependency. We are avoiding join dependency in the fifth normal form. That so properties of normal forms and the decompositions. First normal form, a relation is said to be a first normal form means it contains all atomic values or single values. So if the table, if the relation is in following first normal form means what? Those single attribute having single value. See here example, here domain and course is the attributes. So domain contains the data, programming and web designing. The programming having C and Java, web designing having multi-values, HTML and PHP. So this course column having multi-values. Here C and Java, here HTML, PHP. We should not write like this. That means this table is not in first normal form. How I can convert this into first normal form means we should avoid that. We should write the table in this way. So domain, programming C, programming Java, web designing HTML, web designing PHP. In this way we should write. That means it should contains column contains only single values. We should not write multiple values in a single column. Okay, that's what first normal form. Then coming to second normal form, a relation is said to be a second normal form means it is in the first normal form and dependency. Okay, second normal form represents what? If you are following first second normal form means it should satisfy the first normal form. It must be in first normal form. And the other thing is what? So the form without any partial dependency. So there should not be a partial dependency between the attributes. Okay, there should not be partial dependency between the among the attributes. Okay, so that two conditions, two rules we need to follow. The second normal form means It must be in the first normal form. It must follow the rule of first normal form. And the here condition, other extra condition is what? We should not contain any partial dependencies between the attributes. So the second normal form, non-prime attribute should not depend on the proper subset of the key attribute. Okay, non-prime attribute. Here non-prime attribute is what? See the example, then you can understand easily. See the example. Here student ID, student name, and project ID, project name. Here the attributes. Here student ID, project ID is what? Key attribute. Okay, primary key attribute means composite key. So student name and project name are non-prime attributes. Here candidate key, student ID, and candidate project ID. So these are prime attributes. So other student name, project name are non-prime attributes. So how we can decompose it? See here. So it should not be partial dependency. You should not have any partial dependency. So I am decomposing this table into student ID, student name, and project ID. Then I decompose another table, that is project ID, project name. That means what? This project name fully dependent on the project ID, but not to the student ID and all. Okay, so project name fully depend on the project ID. Okay, so we can convert partially dependence to fully dependence. So that's what's the second normal form. That's what second normal form. The third normal form, a relation said to be a third normal form, it is already in the second normal form. That means it satisfies the second normal form. Then here the condition is what? No transitive dependency exists. No transitive dependency means what? A turns to B turns to C, or to the functional dependency we can represent A turns to C is called the transitive dependency. We should not write like this. A relation in third normal form means if at least one of the following condition holds, every non-trivial functional dependency x tends to y. X is a super key here, y is the prime attribute. Each element of y is a part of some candidate key. Then I can decompose this table into below tables. So student ID, student name, city, country, zip. So student ID, student name, zip is one table, and zip, city, country is the another table. I can decompose it like this. Okay, in tomorrow session we will see the fourth normal form, fifth normal form, remaining concept. Okay, now it's already 1:30. Okay, please be practice, then only you can understand remaining normal forms also. Okay, try to understand this. Okay, right. Okay, thanks for listening to the session. You can leave the session now.